There are different areas within simulation that we also cover within this release, one of which is flow simulation. Now with flow, we've got a couple of really notable things here. One is called a rotating mesh region. Now in areas where the flow is created by something that's internal to the fluid itself, in this case an impeller or an involute, we've always been able to simulate those, but the part itself had to have some representation. This one here is creating the flow. So we'd have to put some turbulent type of value in there and some mass flow rate in order to simulate what it would generate as a real part. Well, with a rotating mesh region, we can actually have that body in there as solid geometry. And instead of it just being in static position, which it would then more serve as baffles more than an involute or a pump, in this case it would actually go ahead and allow us to rotate that mesh region, fully simulating exactly what the input of this in-fluid type of a body would be. So not only can we use it to up the flow, but it's also going to disrupt the flow based on the geometry that is within it and give us great feedback when it comes to any types of problems that might result in that. We also see the preparation results while we're solving. So much like you saw with the nonlinear that we showed earlier, we're seeing the plots generate as the actual simulation is taking place. Also down here we have color-coded leak tracking, and that's one of those things where in gaps that are created in SolidWorks files or any CAD file, frankly, those gaps have a threshold of whether they're determined as a gap or whether they're ignored and essentially sealed up or closed during the simulation. Well, the leak tracking allows us to see those legitimate areas and then be able to go ahead and action on those appropriately as well.